if you have a hypothesis that is of format 3, remember format 3 is the hypothesis that we use when both of our dependent and independent variable is continuous. So it takes the form of something like age is positively related to income, or family size is positively related to number of cars owned by family, something like that. So if you have two continuous variables in your hypothesis, you're going to have to use something called the correlation coefficient. Okay, the correlation coefficient will tell you whether there's a relationship between two continuous variables and the strength of that relationship. Okay, so let's say you have a hypothesis that is something like age is positively associated with number of times a person attends religious services monthly. Okay? Okay, so basically what we're asking here is we're basically saying that we think there is a positive relationship between age and number of times people go to religious services. Older people go more often. It's basically what we're hypothesizing here. Okay? So to answer this, to test this hypothesis, we have to use a correlation coefficient. Oops. Okay. And so I have data here on 15 people. I have whether or not they're male, their age, and how many times they attended religious services in the last month. Okay, so this first person is a man, 45 years old, and attended no times. Next person is a female, 30 years old, she attended 4 times, etc. All 15 observations. Okay, so how do we use Excel to get a correlation coefficient? And once we get it, how do we use it to answer our hypothesis? Okay, so here's what you do. In order to get a correlation coefficient, we're going to tell Excel that we want them to look at the variable age and compare it to the variable attend per month and tell us whether there is a statistical relationship. Okay, and we do this by putting an equal sign, and we use the command correl, which stands for correlation, and then we put a parentheses, and then we highlight the observations for the first variable. Okay, then we put a comma, and then we highlight the observations for the second variable, and we put a parentheses, and then we press enter. Okay, and it tells us that the correlation that we get with these two variables, age and attend monthly, is 0.44. Okay, so that's how you do it. And here's some other things to know here. Okay, once we get the correlation coefficient, we have to determine the size. How strong is it? The strength of the relationship. Let's say, let's call that the strength of relationship. Okay, if the value of this number, okay, which we just figured out there, is the correlation coefficient. If the value of that number is between 0 and 0.1, there's no relationship. If the value is between 0.11 and 0.39, we'll call it weak. If the value is between 0.4 and 0.6, we'll call it moderate. Anything over 0.6, we're going to call it strong. And if it's 1, it'll be perfect relationship. Okay? Now we want to know the direction. Is it a positive relationship or a negative one? Okay? So remember what we mean by negative. A negative relationship means as one variable goes up, the other one tends to go down. Now in our hypothesis, we thought that the older a person was, the more times they'd attend religious services. So we assumed, or we were testing whether there would be a positive relationship. Okay, which means as one variable goes up, the other one goes up. Okay, so The correlation coefficient will be a number between 0 and 1, or 0 and -1. And the size of that number will tell you the strength, and the sign of that number will tell you whether you have a positive or a negative relationship. Okay? 0.44, I look here and I see that that means moderate relationship. 0.44 is positive, so I see I have a positive relationship. So what does this 0.44 tell me? It tells me that I conclude that there is a moderate positive relationship between age and frequency of religious service attendance. Hypothesis is supported. Okay, that's it. Shall we do one more? Let me just add a little bit more, a few more numbers here. Let's say that we have a variable called income, and it's in tens of thousands of dollars. Okay. Okay. Let's say this person is making 40,000. This person is making 30. This person is making 30. This person is making 40. This person is making 80. 55. 25. 55. 43. 25. 18,000. 60,000. 52,000. 40,000 and 25,000. Okay. Let's say then, now we have a hypothesis. I'm just going to put it right here. Hypothesis. Okay, hypothesis here. H2. Age is positively associated with income. So we think that older people will basically tend to have higher incomes than younger people. Okay, so I'm going to have to use a correlation coefficient because age and income are both continuous. So I say equal CORREL. Then I do a parentheses, and I take the first variable, age, and I highlight it, and I put a comma, and then I take the second variable and I highlight it, and I put a parentheses, and I enter, and this is what I got, 0.09. Okay, so that's the correlation coefficient for the relationship between age and income. Okay, so I go over to the interpretation area. The strength of the relationship says 0 to 0.9 is basically no relationship. Okay, so I'm going to conclude no relationship. Of course, it's positive, but because there's no relationship, that's kind of irrelevant. So, conclude. There is no relationship between age and income. Hypothesis not supported. Okay? Boom. And that is how you do a correlation coefficient and how you interpret it using Excel.